Hi my dear students, welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. आज हम चर्चा करने वाले हैं सेशन नंबर 2 solutions and colligative properties. Previous session we discussed about the types of solutions, concentration terms and solubility of gases in the liquids followed by Henry's law. And today we are going to resume from there, and today's my agenda is going to be the applications of Henry's law and vapor pressure, factors that influence in vapor pressure, and Raoult law and other colligative properties. So ready you all? Can you all able to hear me, can see me, so that we can start the class? Hi my dear students, please be active in the chat box so that we can have a discussion. So dear students, before going into the deep dive into the solutions, so you want to dive into the solution, get ready, fun ahead. So I just want to say, before going for this, I have some promotions. In that we can see Infinity Learn by Sri Chaitanya, we are offering Atreya program. This is a designed program for the NEET repeaters, India's most powerful NEET repeaters program. And this program will make you from I didn't know to I will do it. Crack your NEET examination. Introducing Atreya by Sri Chaitanya Academy. We have P square CB program, physics twice a day, and chemistry and biology. Bacho, you have seen the 2025 physics paper. It's slapped like anything. Everybody is blasted like anything. So because you guys feel it is very difficult, and not only you, all the students who are preparing for NEET examination, physics is the nightmare. So Sri Chaitanya Academy, Infinity Learn, we want to take this pain on us, and physics is on us. Now we'll make the physics is as easy as chemistry and biology goes. That is very important. Please, those who are in line online, please like the session. Like the session. I want to see the number of likes during the session. Dear students, so what Atreya program? This Atreya program is enriched with P square CB program. Let me quickly complete this. And this is a program structure, and it started May 23rd, 2025. Don't worry, every week a new batch is being commenced, so that you will be, once you enroll in that, you will be allocated you in a new batch. And the classes are going to be Monday to Saturday, and every class is going to be a 90 minutes class, and 3 classes in a day, so you won't be having that pain. So the program is designed scientifically in such a way that you will be having an extensive preparation, but you will feel yourself not clumsy, relaxed, but everything will be done. So 3 classes per day and 2 concept classes, उसमें एक practice session होता है. Ayush Gupta, hi, how are you? And 18 classes per week, उसमें a double practice class for the physics. The most important point is you are going to see 465 live classes, total 240 DPPs will be there. These DPPs are in the range of NEET examination, and you can see dedicated practice classes 120 hours plus, and after class notes will be given to you, and batch size for the practice class is 20 to 25. 20 to 25 means you will be sitting along with your faculty and will be discussing the practice, and you will be having a customized doubt clarification. So Ayush Gupta, those who are online, please confirm, is my voice is audible? Is my voice is audible? Fine. So let us follow this, and the coverage of total 11th standard and 12th standard syllabus will be there up to the NEET level. So while late, the link is available in the description box. You please click that link and join in that, enroll in that Atreya program, and all the best for your NEET examination. And also, I just want to give you something magic here, NEET test series. Whatever you are preparing, let it be any examination of your interest. So it is required to understand where exactly you stand, how you are doing. For that, a proper assessment is required. For that, Infinity Learn by Sri Chaitanya Academy, we are offering NEET test series. It is for 11th standard and 12th standard as well as repeaters. 3 segments are there. You can choose your segment of interest and you can join it. Because those classes I am giving right now in the YouTube channel, it is extremely useful for both 11th standard, 12th standard as NEET repeaters as well. And when you click that link in the description box, you can see the various details, but don't forget to use this YouTube 30 off coupon code ताकि आपको मिलेगा 30% discount. And what are the highlights of this? Based on latest NTA NEET examination pattern, this test series is designed by the expert faculties from the Infinite Lane by Sri Chaitanya. And also, this is going to give you simulates real-time test taking experience. That's very, very important. When you have that kind of simulation, you sit in the real-time NEET examination, you are going to get awesome picture about the NEET examination. So the NEET examination is going to be a smooth journey for you, right? Now, Violet, my dear children, so let us jump into the deep dive into the solutions. Let us see vapor pressure. What is a vapor pressure? I just want to show you absolutely a super important slides, and it is animated slides, and you can do the best. Okay, take a pen and paper, everybody. Noteworthy points I'm going to give you. You can really write it and you can really enjoy it. Keep in your memory. Reta mat marna, don't by heart it. So what is a vapor pressure? Now when you see this is a liquid, liquid is going to evaporate. When this liquid is evaporating, you can see this vapor is going to condense back. This process is what is called as liquid is converted into vapor, and the vapor is converted back into the liquid. So when the vapor is converted back into the liquid, the vapor molecules, you can see they are coming and hitting back on the surface of the liquid, right? Are you getting or not? So when they hit back on the surface of the liquid, they are going to exert some pressure on the surface of the liquid. That pressure exerted by the vapor on its own liquid at equilibrium is called as equilibrium vapor pressure or vapor pressure, and this is a property of a liquid. Understand? So you like this animation? Ayush Gupta, hi. That's good. So Infinity Lane link is there in the chat box. You just click it and you can see the pinned message and you can enter the details. We will be following you, and please like this session because such a nice animations are given by the content team, and we are going to do the best for it. And you can see calculation of vapor pressure. So how vapor pressure is calculated? At equilibrium, what happened? Rate of evaporation is equal to rate of condensation. When the rate of evaporation is equal to rate of condensation, that equilibrium, what happened? H2O is a liquid and it is converted into vapor, and the vapor is converted back into the liquid state. At that state, you will be having a pressure exerted by the liquid. That is what is called. Hence, the vapor pressure is equilibrium constant of the reaction. So, if you see Kp is equal to partial pressure of H2O. So, it is connected to the equilibrium chapter in the 11th standard. Right now, we are in the 12th standard topic. And so, I just want to say liquid and vapor equilibrium. Vapor pressure of the liquid is equal to Kp is equal to partial pressure of the H2O, right? And you can say H2O liquid and H2O gas. And in that you can see in the vapor pressure, it is simply you can say it is the pressure exerted by the vapors when the equilibrium is established. You can see this is a liquid and this is a closed container, and it is evaporation and this is condensation. That state is called equilibrium state. At that equilibrium state, this liquid molecule exerts some pressure on the surface of the liquid, that is called equilibrium vapor pressure. So based on this equilibrium vapor pressure only, total colligative properties are connected. Okay. Now I want to say in the vapor pressure, technically I want to say the pressure exerted by the vapors, thermodynamic equilibrium with its condensed phase at the given temperature in a closed system. And that is technical definition of the vapor pressure. Okay. And this, based on this, you can derive so many laws. Raoult law and Dalton's law is applicable over here, and you can see all the colligative properties are directly linked to the vapor pressure, right? And into that you can see condensed phase and liquid phase. You can see liquid 10 grams, T is equal to 0. So they are going to evaporate it. So liquid less than 10 grams at equilibrium, the vapors are making an equilibrium with the liquid, right? So this is at the state of equilibrium, you can say, in the condensed solid state. Directly when the solid is taken, directly sublimes at atmospheric temperature and pressure. And also you can see rate of sublimation is equal to rate of deposition, or even you can say condensation. And solids, can you tell me the solids which can sublime? Can you tell me the solids which can sublime? Ayush, those who are online, please. Okay, right. So iodine is going to condense and it sublimate, and camphor, naphthalene, and also you are going to have various systems like benzoic acid, naphthalene, and you have salicylic acid, iodine. These are all sublimative solids, beta. So why they are going to sublimate? They at the melting point they are going to be metastable. Okay, so please like the session who are online. So when you click the like button, that will be visible to me. So the class ka josh बढ़ जाता. Okay, बच्चों. So dry ice, iodine, camphor comes under this solid sublimation equilibrium. You can see the same, the solid iodine or camphor is heated. You are going to see it is heated, it start evaporating, you can see vapors are there. Can you see the vapors? And they are going to condense back because this is closed, otherwise they are going to be evaporated, right? And I just want to say here, condensed phase of a solid, it does not sublime at atmospheric temperature and pressure, and also vapor pressure is negligible. If it is not sublimating, the vapor pressure is not considered. So I want to say here, only the vapor pressure is considered only in the case of liquids. In the case of solids, you don't take in this vapor pressure. Now I want to say it is important to note vapor pressure does not depend on the surface area. Rate of evaporation depend on the surface area, but vapor pressure do not depend on the surface area. Vapor pressure depend on nature of liquid and temperature and intermolecular forces and external pressures as well. Now I want to say here points to be noted, and everybody talk about and study about the theory, but some noteworthy points in my YouTube class you are going to get it. Ayush Gupta, those who are in online, please be interactive. It is a live interactive session and it is not a radio telecast session. So you can have a direct discussion with me. If you have any doubts related to the concept, you can talk to me. Beto, are you online? So you are the student regularly attending my classes. That's why I can remember your name. To have this kind of classes, you need to go to a coaching center for a long distance, travel in the rains, and you have to pay a long way and huge amount of money. But in YouTube channel, the classes from the Infinity Land YouTube studio, these sessions are absolutely free. You can just sit at home and you can and enjoy these classes for the free of cost. So simply take a pen and paper and write all noteworthy points that I am giving to you. बच्चों, please like the session, share with your friends. इन लोगों के भी फायदा होना चाहिए, and subscribe to Infinity Land NEET YouTube channel. Point to be noted here: vapor pressure does not depend on. You can see the condition does not depend on. So जो conditions है पहले, and there are three parameters very important here. Surface area में depend नहीं करता, and the shape of the container could be like this, the container could be like this, and also the amount of the liquid present in this sum. So the vapor pressure do not depend, but the rate of vaporization is different. Okay, that's very important. In the NEET examination आपको एक question पूछा जाएगा. So which of the following the vapor pressure does not depend? Can you somebody mention in the chat box on which parameter it depends? Challenge for you. Don't take the challenge or what? Take the challenge, everybody. In which case it depends. So it depends on comparison, you can say small surface area, you can see a narrow container, a broad container. You can see the vapor pressure is exactly the same as in these two cases. Okay, this is a closed container, bacho. This is a closed container. You understand? It does not depend on the surface area. Okay, this is the comparison. Vapor pressure same hoga. And also you can say vapor pressure does not depend on the surface area. This picture can tell you vapor pressure does not depend on the surface area. Are you getting or not? That's good. And also comparison, you can say large surface area, small surface area, the same thing is going here. Factors affecting the vapor pressure. That is very important. That is very important, bacho. Okay. Now, factors affecting vapor pressure depend on surface tension and the temperature. Surface tension किस में depend करता है बेटा? Surface tension किस में depend करता है? Vaporization depends ना? हाँ, अनिकेत, vaporization बिल्कुल depend करता है बेटा. Surface tension depend on nature of liquid. जिस लिक्विड को इंटरमोलिकुलर फोर्स कम है उस लिक्विड का वेपर प्रेशर कम हो ज़्यादा होगा. सो वेपर प्रेशर inversely proportional to intermolecular force like London dispersion forces, dipole forces, hydrogen bonding जैसे. Aniket, yeah, viscosity. And talking about the surface of the bulk liquid, you can see when the surface tension is more and higher the intermolecular forces, higher is the surface tension and lower is the vapor pressure. When there is a strong bonds among the surface, they are not ready to leave this liquid. Understand? समझ में आ रहा है क्या बेटा निकेत? And also you can see effect of surface tension. The intermolecular forces at the surface would directly influence the surface tension, which varies inversely with the vapor pressure, right? So we can say hand sanitizer, you can see it has what are the things you are going to have the composition like this. See, ethanol 70% volume by volume will be there. Because of that, its vapor pressure is going to be more. That is the reason why hand sanitizer you are going to have more vapor pressure. You understand? And this is a broad spectrum antimicrobial, and this sanitizer we all seen. Propan-2-ol is also used, and that is better. Propan-2-ol is better than ethanol. Okay. And talking about, you see the vapor pressure, how it is observed. Okay, it is a water. Okay, in that you can say take some water and you add some alcohol. So sanitizer is going to be evaporated and the water is not evaporated. Why? So water has a strong hydrogen bonding, whereas sand sanitizer has ethyl alcohol, has less hydrogen bonding, so that they have more tendency to evaporate. Are you getting or not? This is the beautiful version of learning subject beta. You all like this? Aniket? You all like this? Fine. Now let us talk about effect of temperature. So you know kinetic energy is directly proportional to absolute temperature. Kinetic energy is directly proportional to absolute temperature. Therefore, what happened? Low temperature particle have low average kinetic energy. At high temperature, the particle has high kinetic energy. So, high kinetic energy means critical temperature difference. Critical temperature comes in the liquefaction of the gases. Okay, Aniket, the gas with high intermolecular force will have higher critical temperature, can be easily liquefied, can be easily soluble. Aniket, that comes in the Henry's law. That is about gases. We are talking about the properties of the liquids. ठीक है बेटा? And so higher the temperature, vapor pressure will be high. So as temperature increases, kinetic energy increases, tendency to evaporate liquids increases, and the vapor pressure also increases. Are you getting or not? Clear? And you can see effect of temperature, temperature of the given liquid. You can see here At high temperature, more molecules from the liquid have enough kinetic energy to escape out of the surface area of the liquid, so that this will increase the saturated vapor pressure. So, as temperature increases, vapor pressure increases. Learn the subject firmly from the scratch level. So, you should be fundamentally strong. Therefore, you can apply the subject at any angle and at any depth of the concept. Aniket, Ayush Gupta, Betu, all there, right? Yes, now liquid vapor equilibrium. So, delta H is going to be positive. Enthalpy of evaporation, delta H is called enthalpy of evaporation. Heat required to evaporate 1 mole of liquid into vapor is called as enthalpy of evaporation. It is always endothermic process, because liquid has less energy, no? And vapor has a more energy, no? So, energy of the system is increased, so that you are going to have this process is going to be endothermic process, right? And you can see vaporization of the liquid to the vapor is always endothermic process, and you can see heat is required to convert the liquid into the vapors. That is called enthalpy of evaporation. Sometimes it is said to be standard enthalpy of vaporization. Different books and different terminologies they are using. Okay. Hi Vaishnavi, how are you? Now, you can see according to Le Chatelier's principle, increase the temperature of a system, the dynamic equilibrium is going to be shifted in towards the vapor side. So, it is an endothermic change. As temperature increases, vapor pressure increases. So, increase in the temperature increases the amount of vapor present and increases the saturated vapor pressure. समझ में आ रहा है क्या? We are applying a Le Chatelier principle. So, effect of temperature. You have Clausius equation, Vaishnavi. You have a Clausius equation to explain this. I am going to explain that also. Okay. Aniket. Yes. So, let us talk about effect of temperature on the vapor pressure of a liquid is given by Clausius-Clapeyron equation. So, let us say at T1 temperature, the vapor pressure is P1, and at T2 temperature, the vapor pressure is P2. So, how this P1 and the P2 are related? It is from the Arrhenius equation it is given. Ln P2 upon P1 is equal delta H by R of 1 by T1 minus 1 by T2. Okay, Vaishnavi, please like the session. This is what is called as a Clausius-Clapeyron equation. And you can see delta H is the enthalpy of evaporation, and P1 is the vapor pressure of the liquid at temperature T1, and P2 is the vapor pressure of the liquid at temperature T2. Right? It is a very important. Equation. You need not have to do numericals based on that. Okay. And vapor pressure versus temperature of a water. Let us see how it is going to be related. It is exponentially increases. Vapor pressure increases as temperature increases exponentially. You can see it is exponentially, it is increased. Aniket, you understand this? And this graph can help you to understand Raoult law. This graph can help you to understand the elevation in boiling point. This graph can help you to understand depression and freezing point. Exactly, it is very important, my dear students. So, let us talk about, okay, that's a different parameter. Yeah, vapor pressure of liquid solutions. Vapor pressure of liquid solutions, Vaishnavi. Solute, volatile liquid. Solvent, volatile liquid. So, what is a solute? In a binary solution, the one which is present in less number of moles is called solute. The one which is present in more number of molecules is called a solvent. Now, this is a vapor pressure. Here the vapor pressure consists of both components of the solution. So the partial vapor pressure of each component depends on the mole fraction of the corresponding component. This is actually technically said to be Raoult law. So I just want to show you how the vapor pressure of the component is measured. So let's see. So Raoult law, let us see the technical difference. So you have a liquid A and this is a liquid B, and liquid A has its vapor pressure in the pure state, liquid B has its vapor pressure, and this is what is called as a P naught A, that is a pure liquid vapor pressure, Aniket, and it has a pure liquid vapor pressure of B, and it is going to be pure solvent PS. So it is equal to total vapor pressure. This total vapor pressure is explained on this way. So I want to say it all depends upon its mole fraction. Dear students who are online, please like the session. I am going to explain by animations, I am going to explain technically, theoretically, and I am going to give you tricks for that also. So let's say XA is the mole fraction of A. XA is the mole fraction of A here. Okay, it is coming, wait, yeah. You have the mole fraction of A, that is called XA. You have the mole fraction of B, that is called XB. Okay, so I want to say the partial vapor pressure is directly proportional to, here the partial vapor pressure of A, this is partial vapor pressure of this is called as PA is directly proportional to mole fraction of A, and PB is directly proportional to mole fraction of B. So ताकि आपको पता चलेगा PA is equal to P naught A mole fraction of A and PB is equal to P naught B mole fraction of B. So what is the basic difference between P naught A and PA? P naught A in the pure state, PA is in the liquid solution state. So of course PS is equal to PA plus PB, PA plus PB. I mean to say PS is equal to P naught A mole fraction of A plus P naught B mole fraction of B. So these are the things you need to know, and that's what I want to say. XA is the mole fraction of A in the solution phase, XB is the mole fraction of the B in the solution phase, and P naught A the vapor pressure of A in the pure state and P naught B in the vapor pressure of B in the pure state. And when they combine, considering both the system components A and B, the obey Raoult's law, partial vapor pressure of A, I mean to say PA is equal to P naught A and mole fraction of A, mole fraction of A. Okay, partial vapor pressure of B is equal to PB is equal to P naught B mole fraction of B. Okay, P naught B and mole fraction of B. That's what we explained here, right? And you can see for a solution containing two volatile liquids. So partial pressure of each component of an ideal mixture. What is the meaning of an ideal mixture? The mixture of liquids, the liquid solution which obeys the Raoult law is called as ideal solution, and the vapor pressure of the pure components multiplied by its mole fraction in the mixture. I mean to say PA is equal to P naught A mole fraction of A and PB is equal to P naught B mole fraction of B. That's what it is said. Understand? So partial pressure of each components of the ideal mixture of the liquids is equal to vapor pressure of the pure component multiplied with mole fraction of the solution, mole fraction of the component. Yes, that is what is called as a Raoult law for liquid solutions. समझ में आ रही क्या बेटा बच्चों? You understand this? Clear? And also see the Raoult law. So the vapor pressure and the mole fraction. You are going to see a straight line and the angle is going to be theta, slope is going to be theta, that theta is going to be P naught, mean to say vapor pressure of the pure component. Samruddhi, hi. How are you? And please like the session, please like the session, everybody who are online. And we are going to use this to talk about the ideal solution and its parameters, right? Now you can see vapor pressure and mole fraction. As mole fraction increases, the vapor pressure also increases. That's what it is said to be. P A is directly proportional to P naught A mole fraction of A. PA is equal to P naught A mole fraction of A. Right? Thank you very much, Samruddhi. And also you can see, right? Also you can see vapor pressure of B. PB is equal to mole fraction of B. PB is equal to P naught B mole fraction of B. So you can say vapor pressure of P2, you can say. So you are going to be like this. A is written in this way, B is written in this way, both are mixed. Now you are going to see the ideal solution behavior. I want to say, if A and B are there, now it is all about A and B components are there. A component is shown like this and B component is shown like this, and this is the solution component is shown like this for your better understanding. Okay. So, Samruddhi, thank you, and all students who are online, please observe the graph and let me explain you. Please like the session. Before that, you are going to get PA is equal to P naught A mole fraction of A. This line indicates. What is this line indicates? That is equal to PB is equal to P naught B mole fraction of B. See how much effort we are putting from our side to make you to understand. Please like this session and please share this session with your friends and subscribe to Infinity Line NEET YouTube channel. Please like this session, everybody online. Now what this line indicates, that is called P total is equal to P naught A mole fraction of A plus P naught B mole fraction of B. So to have this, any solution which obeys this graph, that is called, it is obeying its Raoult law. So it's said to be, it is an ideal gas. Okay. And moving ahead, P total is equal to PA plus PB. Who said this? Who said this? Raoult? No, Dalton. So what Dalton said? Partial vapor pressure. So the total pressure of the gas is equal to the sum of the partial pressures. That is called as Dalton's law of partial pressures. That is called as a partial pressures law, Dalton's law. Now we can say P total is equal to PA plus PB, applicable only for non-reacting ideal gases. Non-reacting ideal gases, if they react, now scenario is going to be different. You have to use law of combining volumes that we don't use here, non-reacting gases. So PA is equal to P naught A mole fraction of A and PB is equal to P total. So YA, it is YA. So YA is the mole fraction of A in the vapor phase. You have the liquid phase here, you can see, yes. Yes, in this you have, this is what is called as a mole fraction of A, this is what is said to be mole fraction of A, and this is what is said to be mole fraction of B, and in this case you say it is called YA and it is going to be YB. So if it is in the liquid state, use X, if it is in the vapor phase, use Y. Based on that Y, you can say YA is the mole fraction of A in the vapor phase, YB is the mole fraction of B in the vapor phase. So mole fraction of A in the vapor phase is equal to PA upon PT. Based on that, you will be having a couple of questions. Similarly, mole fraction of B Similarly, mole fraction of B is equal to PB upon PT. PT means total solution, which is mole fraction of A, mole fraction of P naught A, mole fraction of A plus P naught B, mole fraction of B. Understand? Clear? Now moving ahead, from this you can write various derived equations. So you have these equations are rewritten. Please take a note of this. So based on this numericals we are going to do in the next forthcoming session. So first part 1 and part 2 I want to take the concept inception, and we will be having these sessions again. We will be having a practice sessions also. So stay tuned. That's the reason why I ask you to just subscribe it. Whenever sessions are going to be scheduled, it will be notified to you guys. Okay, Samruddhi, hope you are understanding. Simply say hi. Aniket, fine, any doubt? Aniket, fine, any doubt? Now let us talk about the interaction between the liquid solutions. That's very important. When a liquid A and a liquid B is mixed, they start interacting. So they are going to form a homogeneous mixture. When they form in a homogeneous mixture, bacho, when a solute A liquid dissolves in the solvent B, which is also liquid, the extent of dissolution depends on various factors. So what are the various factors you can see? Factor number one. So you can see it is missing. Okay. So various factors. So A interaction and the B interaction and the AB interaction. So A molecule and A molecule getting interacted before you dissolve, and B molecule and B molecule getting interacted. Okay. And once they mix together, A and B, it is a homogeneous mixture. Therefore, A and B should start interacting. Can you see the animation that is being shown here? Right? So that's what I wanted to show. If this is A, so there is an intermolecular force between A and A. Okay, like this. Okay. When you have a separate B, so B molecules are also having intermolecular forces randomly. So what happened when A and B are also mixed? So they start interacting. They start interacting. What do you say? So the magnitude of the AB interaction tells you the actual behavior of A and B and the solution. Yes or no? Intermolecular force makes the behavior of the solution. Now that's what I want to say. The ideal solution, इसमें क्या होता है? Solvent solute interaction is equal to solvent and solute interaction, and this is A and B दोनों का interaction जो देख रहे हैं ना, ये बराबर देखते हैं. Can you see something is animated here? Can you see that? Yes. Exactly. Now that is what is say enthalpy of mixing is 0 and the volume of the mixing is 0. What is the meaning of that? If A and B is mixed, there is no heat loss, there is no heat gain. And also delta V mix is going to be 0. I mean to say that 10.00 milliliters of A and 10.00 milliliters of B is mixed. You are going to get 20.00 milliliters. It cannot be greater than 20 or it cannot be less than 20. For a non-ideal solution, there may be 0.01 value may change. That's the reason why there are said to be an ideal solutions here. So ideal solution where it obeys Raoult law, this has to follow the condition intermolecular force should be the same. That is the criteria to form an ideal solution. Based on that, all parameters will be decided. And you can see anyways when a solution is formed, dissolution process, entropy is always greater than 0 and it is going to be a spontaneous process, my dear children. It is going to be a spontaneous process. Understand? And let us see the more details about this. Example, N-hexane and N-hexane obtain, and bromomethane and chloroethane and chlorobenzene and bromobenzene. Okay, and these are all the examples. So do we have to memorize this? I absolutely say don't memorize it. You can observe the intermolecular forces. The magnitude of the intermolecular forces can tell you whether it is forming an ideal solution or a non-ideal solution, or a positive deviated and a negative deviated. Understand? Now let us talk about ideal solution here, bacho. Let us talk about ideal solution. Yeah, the solution which obeys Raoult law. The solution which obeys Raoult law over the entire range of concentrations are known as an ideal solution. Okay. So then what are non-ideal solutions and condition for this you are going to see. Ideal solutions, where you can see the vapor pressure already we have seen. Vapor pressure of 1 Pa is like this, and the vapor pressure of B is like this, and it is going to be a solution. So this is a linear plot, and it is any solution which obeys this graph is called as an ideal solution, right? And if it is a negative deviation, the graph is coming down. If it is a positive deviation, the graph is coming up. They are called non-ideal solutions. Positive deviation, negative deviation. Let us talk about non-ideal solution. So non-ideal solution, the solution which do not obey Raoult law at all concentrations are said to be non-ideal solution. So let's see the details about the non-ideal solution. It could be a positive deviation or it could be a negative deviation. So this is supposed to be an ideal solution behavior, right? But you can see non-ideal solution mein kya hota hai? It could be less than this. So it could be here positive deviation from Raoult law or negative deviation from Raoult law. So if it is a positive deviation, the line should come like this. If it is a negative deviation, the line should come like this. So this is the benchmark you need to understand. Okay, so we'll discuss that. Now positive deviation, negative deviation, दोनों का क्या अंतर रहेगा? So बच्चों, you can see here. So solvent solution interaction is less than the solvent solvent interactions. So that whenever intermolecular force on dissolution decreases, vapor pressure should increase. Okay, so intermolecular force decreases. Intermolecular force decreases. That is the key point. So when A and B are mixed, any factor which disrupt the intermolecular force, you can say this. But here negative deviation. So when you mix, intermolecular force increases, so that vapor pressure decreases. So how do you explain about this? You talk about water and ethanol. So water, you have a strong hydrogen bonding. Okay, strong hydrogen bonding. So when you add ethanol, ethanol means C2H5OH. Because of this, see, alkyl part is going to disrupt. You understand? Intermolecular force is decreased, so that vapor pressure is increased. So that it is going to increase the vapor pressure. So you need to know the chemical bonding level to understand the total physical chemistry, total organic chemistry or inorganic chemistry. Chemical bonding is a spine for the entire chemistry. Now let us talk here. When you see here acetone and chloroform. So what happened? Acetone and chloroform. So acetone do not have intermolecular hydrogen bonding, CH3, C double bond O and CH3. And chloroform, Cl carbon, hydrogen, chlorine and chlorine. Because of the strong electronegativity of the chlorine, it is going to establish a new hydrogen bonding between these two. Because of the new hydrogen bonding is established, intermolecular force is increased, vapor pressure is decreased. It is a negative deviation from Raoult law can be seen. Okay. So, like this you can see delta H is going to be when enthalpy of mixing is going to be greater than 0, it is an exothermic. Exothermic. Why exothermic? Bond is broke. When the bond is broken, it is heat is released. Okay. And here you can see now positive deviation and negative deviation. Solvent solute interaction is less than that of solvent solvent and solute solute interactions. That's what I want to explain you. Okay. So V mix is going to be 0, V mix is less than 0, and positive deviation and negative deviation. In both cases, entropy is going to be greater than 0. Okay, because this is a entropy of the system is going increased and the Gibbs free energy is also decreased. Both processes are going to be spontaneous. And ethanol and acetone, CS2 and acetone and phenol aniline and CHCl3 and acetone are the examples of these. You need to memorize it, you memorize it or don't memorize it, and you just take the intermolecular force into the action and you can do it. Okay. Now talking about ideal solutions and non-ideal solutions. Ideal solution means they follow Raoult law, so that Pt is equal to mole fraction of A P naught A, mole fraction of B P naught B at all temperature and the composition. While the positive deviation do not follow Raoult law, and P solution is greater than sum of Pa and Pb, and negative deviation do not follow the Raoult law. P solution is less than P naught B mole fraction of the solution. Okay. And you can say intermolecular forces before and after mixing is going to be the same. Intermolecular forces after mixing is less, positive deviation. Intermolecular forces after mixing is greater, it is a negative deviation. So these are the key points you need to learn about the deviations. And let us see, the benzene and toluene, water and ethanol, water and acetic acid comes under these various examples. Okay. Any doubt? And now you can see vapor pressure of the boiling point. And what is the meaning of boiling point? At the temperature at which a liquid starts boiling is known as boiling point. Is that true? Okay, visually it is true, but the temperature at which the vapor pressure of the liquid is equal to atmospheric pressure, external pressure, that is called as a boiling point temperature. You can see gas particles and liquid particles. So when this start boiling, now what happens? You can see vapor pressure on the boiling point. So the water vapor on the surface, they are going to make a collision. Air molecules are going to make a collision. So atmospheric pressure is exerted on the surface of the liquid, right? And the collisions of the atmospheric gases with the liquid on the surface takes place. To avoid that, you need to have the, if the vapor pressure is equal to that, so the opposing forces are going to make the visual turbulence on the surface, that is called boiling. And you can see here, and the vapor pressure increases, you see when the temperature is increased, so what happened? This vapor pressure is equal to the atmospheric pressure, making easier for the liquid molecule to spread from the vapor. So the vapor pressure and the atmospheric pressure be equal at that temperature, the solution start boils. Okay, that is what is called vapor pressure is equal to atmospheric pressure. That is called boiling point temperature. Are you getting or not? Clear? Now liquid molecules start boiling when the vapor pressure becomes equal to the atmospheric pressure. You see it continuously, so that when this is equal to this, na, it is going to just make a turbulence. That is called as the boiling. Are you getting or not? So you love it, you love it. And you know the temperature and the vapor pressure. This is the vapor pressure and this is the temperature. So the vapor pressure and temperature, we all know it is going to be exponential graph. I said this exponential graph is important. When this temperature, so you can see this is 1 atm pressure or 1 bar pressure, and you are going to extend this line, my dear students, and this is the temperature, and this is called as the boiling point temperature of the liquid. Understand? This is the boiling point temperature of the liquid. Now you can see points to be noted, very important point. Bacho, you are all enjoying the lesson. Nice animations, na? Samruddhi, Vaishnavi, Aniket, Betu, all there on the line. Please like the share, like the button once, share with your friends, subscribe to Infinity Lane NEET YouTube channel. Right? Now you can see if a liquid has a high vapor pressure at a particular temperature, it means its molecule can escape easily from the surface. Right? And also you can see if the liquid with the high vapor pressure is in a particular temperature, is the one with the lower boiling point can be seen. So the vapor pressure and the boiling point. So the boiling point is directly proportional to intermolecular force, and the vapor pressure inversely proportional to intermolecular force. I want to say boiling point inversely proportional to the vapor pressure. These are the things we need to know. Bacho, hope you are understanding. I want the like number should increase in the class. Those who are in the online, please like the session. Requesting my students, please do that. Okay, and also you can see colligative properties. So I just want to talk just introduction about the colligative properties. So the properties of the liquid mixture depends only on the number of solute particles, but not on the chemical nature of the solute, chemical identity of the solute. Such properties are called colligative properties, and these colligative properties are relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Right? So these are the various colligative properties. Bacho, I just want to discuss these colligative properties in a separate session where we are going to see real-time application of this. And today's session we completed applications of the Henry's law and vapor pressure, conditions for the vapor pressure, and we have Raoult law and applications of Raoult law, and Raoult law positive deviation and negative deviation. In Agle class again we are going to come back to the Raoult law and we will talk about the relative lowering of vapor pressure and elevation in boiling point, depression in freezing point, and osmotic pressure. हाँ, और एक बात है, you see for colligative properties these are applicable for the solute. The solute supposed to be a non-volatile solute, and the colligative properties, the solute must be non-volatile, then only it is right. So we are done from my side. Please like the session, okay, and share with your friends and subscribe to Infinity Lane NEET YouTube channel. So thank you very much, and signing off, Suresh, Faculty of Chemistry from Infinity Lane. Augie Don, hi. At last when I say sign off, you are saying hi. You please like the session. Thank you very much, Bacho. Thank you. Please like the session. Thank you. Bye-bye.